Hello everyone, we're Team 6. Our project topic is post-welfare air quality prediction in California. We want to do this topic because we all know that when California is in wildfire season every year, the air quality out there is very bad. And since wildfire have many harmful impacts on the environment, we want to dig deep into the impact of the wildfire human living conditions, especially in air quality. Our project only focusing on wildfire happened in California, and the time frame we choose is between 2000 and 2015. Our project objective is to use wildfire features and weather features as input to predict air qualities in terms of CO, PM 2.5, and ozone through 3 machine learning models. The first thing we did is to select columns related to our project. And then we convert those time-related column into date time object in order to get the data set ready for machine learning model training. Since the wildfire duration is a important metrics of wildfire, but the raw data set does not have the duration. So what we did here is calculating fire duration and add the result as a new column, and then give the column a name as duration.
Yeah, so because our original data doesn't have the field about the county code, so we basically fetch our FIPS codes through by the longitude and latitude through the government API. And this is how we get those data down. And also when we comes to getting the air quality data, we are fetching our air quality data through the EPA government public API and saving them as the CSV file. So this is the function we are fetching those data. And also after we pre-process all of the data and also merging them together, then we are going to pick our needed features and target columns. So we totally have 6 different columns and also 3 column for value as the values. Then we also get dummies for the FIPS code.
So, okay, so over here, what we do for the data engineering part after the whole data cleaning and data conversion step is done is we need to put it inside our scikit-learn model for the scikit-learn model to be able to separate our whole data set into training, testing, and testing set so that our deep learning model is able to process it well. Next page, please. Okay, so basically we pick 3 machine learning models. So basically we pick 3 deep learning models plus 1 baseline machine learning model. So the 3 deep learning model we pick is ANN, GRU, and RNN. So and then 1 baseline model for the basic machine learning model is our linear regression model. So as we can see from our first deep learning model from our ANN, so which is actually one of the models that performs the best. So as we can see, we have a total echoes of nearly 1,000. We can see from the echoes number from 0 to 400, the model is doing its job and it's dropping significantly. Therefore, as we know, so the loss change for the ozone is the loss change for the ozone is progressing as the model continues with its epoch. Same as for the loss change for CO and loss change for PM 2.5. And then next page. So as we can see, this RNN model So this recurrent neural network model, it doesn't perform as well as our ANN model. So one of the reasons is because actually this model this model only contains 100 epochs. The second one is because even though the model contains 100 epochs, but as we can see from our log change for ozone, only the nearly from 0 to the fifth epoch is dropping, and then it's not even dropping for the testing sample. So it's not actually a good model. Okay, next page, please. So GRU model is GRU model is our third model, which is our last model we pick for the welfare prediction task. The reason we picked the GRU and the the recurrent neural network model is because both of these models takes the time component into consideration. This GRU model specifically puts more heavy weight on the time as well. So it uses the update gate and reset gate to correctly calculate the time factor inside our prediction, but it doesn't perform as well as the basic native artificial neural network model, as Michelle is gonna discuss the specific loss and test numeric so that we pick our ANN model.
As David just mentioned, we have used 3 different machine learning models on the data set we got, but we have to choose the one that has the best performance among the 3 models. This slide and the following 2 slides show that the ANN model outperformed the other 2 models in terms of loss. No matter which error quality metric was put into the model. Besides that, when we took the time efficiency into consideration, the ANN model had the lowest runtime when compared with the other 2. Therefore, we decided to choose the ANN model as our ultimate model to predict error quality values and use the ANN model as the underlying model when we build our website for the demonstration purpose.
Okay, so now let's navigate to our welfare prediction website, which includes all the features in here.
Okay, hello everyone. What you're looking at is our homepage for the website we have built. This website is fully functional and it pretty much concludes everything we've done through the project, from data collecting, visualizations, and make live predictions using our machine learning model. There are 6 tabs on the top, and we will talk and go into detail about each of them later. At the bottom, we've gathered some stats to just show you guys how much damage the wildfire have done to our environment as well as the economy. When we want to scroll down further, these are the 4 machine learning models we have tested, and we decided to use ANN for final model prediction in this because it has the best accuracy among all others we have tested. So if you want to click onto the next tab, here are all the raw data we have collected with all the detailed info, with all the important columns we have gathered and generated. If you click on data source, source data, it'll show you where we got the data from. And we surely downloaded data sets from all kinds of sources, such as Chicago EPA website, which stands for Environmental Protection Agency. Just like any other project, collecting data definitely takes up a lot of our time so that we could use it to fit in our model. So as Professor Gao suggested, we will not include this page in our actual website when we publish it because we do want to have it in here so to show you guys some of our data. They are followed with the steps to prepare the data. So the first step is fire data cleaning and feature selection. And then we performed serialization onto weather data. And then step 3 is to get the data ready to fit in the machine learning model. So yeah, move on to David.
Yes, so basically I'm going to briefly mention our 2D and 3D plots. So basically the 3D and 2D plot is the process we do when we are performing our exploratory data analysis project. So during our EPA process, during our EDA process, the reason we want to generate these plots is because not only we want to make ourselves aware of the situation we are dealing with, but also we want to make sure our model is indeed accurate and our prediction makes sense. So basically, for the 2D plot is the variation of air quality before and after major wildfires. What I mean by major wildfire is for those California wildfire that cannot be contained more than 100 days. So basically, a wildfire can last for more than 100 days or 70 or 80 days. That's what we put as a major fire. So one of the fire happens in 2008. We can see the impact of it on the ozone level. So as we can see, the highlighted red portion is where the fire is lasted. As we can see, it lasted all the way from June to nearly the start of the December. So as we can see, the ozone level is actually changing during this interval, and we can see it's definitely higher than the interval that is not being highlighted, which means the wildfire does have an impact on our weather prediction. Maybe this graph is not as obvious as this one. This one is our ozone value change in 2001. This is another major fire. As we can see, this is actually so this impact of the wildfire is actually more significant than the one I'm actually just show you. And we can also do the same thing on the PM 2.5 and the CO value, which is also our two additional metric. And our 3D plot is what we do for our better understanding and into a higher dimension. So basically, the 3D plot has three axes: x-axis, y-axis, and z-axis. And then the reason we want to include the 3D plot is we want to see the variation of the air quality based on not only the time, but also the fire size. So let me click on one of those. So for example, this one, the PM 2.5 value change in the year of 2005. As we know, the wildfire in California is significantly seasonality based. So what I mean by this is the wildfire is more likely to happen during the summer, the end of summer, or the beginning of the autumn. So as we can see, this fire size on the y-axis correctly depicted those major fires that has a significant large fire size. The z-axis, which is the target axis we are interested in, is our PM 2.5 level. And this can be changed to CO value and the ozone value as well. And then we can also see that each day in the year of 2005 for the x-axis, just like it confirms our theory that the fire is significantly season-based. And then our next tab, which I'm going to show you, is our first type of the air quality prediction. So we have actually in total of two air quality prediction. The first one is basically for any of the hypothesis fire that any people want to know. So for example, this fire is imaginary, it's purely imaginary. It is not a history fire or a future fire or nor a current fire. This is just, so this tool will be built is for the scientists or firefighters who are still not in the fire season, but they want to see how likely the fire is gonna affect our environment. So they can use this tool to allocate the resources, and then they can use this tool to better understanding the fire impact. So for example, if I'm one of the firefighter and I'm interested in know what happens with the Los Angeles during the following summer, I can make any estimated fire size, make any estimated duration of the fire, the mean precipitation for the weather at the fire condition, and the mean temperature for the fire duration, the max temperature for the fire duration, which we can get a better result. So therefore, on our right-hand side, you can see, so all of those metrics are dynamically changed when the machine learning model is finishing its job. So let me click predict. So it says confirm the prediction value of those key metric, which we need for our machine learning model input feature. So we can see those CO value, ozone value, and PM 2.5 value are showing there correctly. And as we can see, this blue dot is indicating the level of the CO, and this blue dot indicating the value of the PM, the value of the ozone. As we can see from the different legend over here, each of the legend is different. The reason is because each of the CO, PM, and ozone follows a different standard of the comparison. So for example, the ozone value is healthy from 0 to 0.01, and then the PM value is healthy from the 0 all the way to 5. So therefore, we cannot make a standard uniform legend for all of the three. Each of the three has its healthy, dangerous, and extremely dangerous in different level of the numerical value. Okay, Austin, go ahead.
Okay, sure. So when we comes to the final service we created, so this service is basically can predict can help the user in California to predict the air quality that the fire is happening currently. So before I go through this page, let me tell you about how our data flow look like. So this page shows our how we build this website. So we are getting all the current wildfire happening in California using the Iris API, and when we get our current fire data, we can render those fire data on the Google Map using the Google Map JavaScript API. So after we rendering those fire information, then when the user want to predict a specific location's air quality prediction, he can click on the button and which will show on the right part, and we will render we will predict our air quality future 5 days air quality using the same logic as our previous service. And when we predict those 3 matrix air quality future value, we will render those value drawing a dashboard and also using the AnyChart, and also drawing a line chart, use the same library AnyChart. Then we also provide the one external bonus feature which can predict the weather, future weather day, future 5 weather days using the open weather map API. And also based on all the information about the future 5 days weather and also the future 5 days air quality prediction, we will give a recommendation about for the user about their traveling strategy. And they can travel outside, or they should wear a mask when they go outside. So this is our data flow looks like. Then when it comes to our website, on the left part, it's there is a map rendered on the left part. So when we starting this page, we will get our get all the current kind of wildfire happening in California, and so it will shown on this map. And so here there are 3 wildfire happening in California, and each one of them represent one single wildfire. So the center of this point is shows the location of this wildfire, and also the radius of this circle represents the size of this fire. So like when we click on any of those fire, then it will shows all the information about the fire, about this fire, like the fire location, the fire site, and also the starting time, as well as the predicting control time. So like when we click on the predict air quality, then it will go through the same logic as we mentioned before, and then on the right side part, it will shows our prediction about those 3 air quality metrics. So here is the CO prediction, and this is the line chart, and this is also dashboard, and also is the pretty same for the PM 2.5 and also the ozone. And also when we for the final tab, it will shows our future 5 days weather, and here it shows the humidity, the temperature, and also yeah, and also the wind speed. So based on all this all the 4 prediction information, we will generally give the user the strategy about whether they should go out or not. So here shows the terrible air quality. Please wear a mask when going outside. So, and yeah, and also one more thing I want to mention is that on the top of this, there are 6 tabs which shows the which there is a correlation between the between the color and also the severity. So this color actually maps with this dashboard. So if this line points to the yellow, which means right now the CO value is the moderate, and also like if the ozone value and like the ozone prediction here is should be the unhealthy. So as the same thing, we also have those for the other three files, we can also have the same functionalities. Yeah, so this is the last service we created, and then when it comes to our final page, which shows our 4 team members information here. Yeah, that's pretty much about our presentation.